Good afternoon, dear colleagues. My name is Sergey Tkachenko. I'm a candidate of science at the Institute of Mathematics and Information Technology under the university in the Immanuel Kant University, one of the founders of the Banking Information Technology Master Program. And so I'd like to talk about projects that students run as master papers. I can't skip the fact that a lot of topics were proposed by the students after visiting AI Journey 2019. The implementation of joint master's program started in 2018. At the design phase, a vector was set to have all the degree papers to be focused on creating software for banking, including a core or a module that would have AI or machine learning as part of it. There's no doubt that implementing this work is a complex task for every participant in the learning process, students and faculty as such, including the management. But the professionalism of the faculty and the perseverance of the students and also the support of SBIR allowed them to create exciting projects. An example, this is work by Dmitry Burkin and Artyom Mikhaenko, automation of user application process in a bank organization. That's a big project devoted to the acceleration of interacting between employees and clients of the bank. The guys developed a number of modules. Let me dwell on two of them. Firstly is the module that identifies named entities, like personalities, cities, counterparties, and organization. A model was created through the hybrid approach, combining the bidirectional LSTM model and the CRF model. So joining or merging this model allowed offsetting the negative aspects of each of them. So the high values of metrics were resulted. Also, there was the classification module developed that allowed processing text and voice applications and classify them to process text data. Neural network methods were used, for instance, by LSTM network, and neural networks were used. As a result, through the recognition of named entities, it appeared possible to identify names, terms from the application, and process them automatically. This one shows the overall view of the system, acceptance of applications from other solution, and an example of text. The next work, Anton Demchenko, bank client voice identification system development. The idea of the work is in accelerating the work of a teller using voice identification of a person. But there's the catch. How the teller, or actually phone agent, should understand that the one who's calling is myself. For this, the system must get my voice, compare it with voice signatures stored in the database, and offer the agent the answer, confirmation that this person is the one that they're posing as. Because the system turned out to consist of three of the following parts: the voice signature storing feature, data signature, and the comparison engine. In order to use the voice prints, a neural network was created. SyncNet architecture was chosen as best fitting to support voice data. And here you can see on the left is the digital signature, imprint, and on the right, the outcome of the system. It's a recommendation after analyzing the voice of the caller. The system offers similar profiles, and it's obvious that it's up to the agent to choose what they need to. The next work is by Tatiana Kovekina and Polina Mayorova. It's a development of blockchain-based transaction security system development. The purpose of this work is to ensure security of customer transactions based on blockchain technology. A mobile app was developed interacting through an API with the server side. The web service was implemented in such a way as to provide the base level of protection. They use tokenization and hashing, password hashing, and all possible traditional methods of protection. But in addition to them, a service was developed that allowed executing transaction, keep them in a repository, and it was based on the blockchain technology. This service, apart from storing, allows verifying the integrity of the information and its correctness at any point of time. So basically, what this system allows to do, it does allow to make transactions safer because they are now decentralized. And this slide shows you that there were 4 nodes, blockchain nodes implemented. It was enough to show the operation of the system as such, and also to simulate how one node goes down, and it proved that the system retained its resilience and stability. On the right, you see a screen of the mobile app developed. The next work is one by Daniil Paganov, a development of classification model based on document scans. The idea was to simplify the work of a bank officer, a person who needs to deal with a lot of documents as being a large part of their work. But the problem we encountered that the documents as such don't have a data set. So we made a decision to generate them, based on which the system consists of 2 parts. Firstly, the module for primary processing of the document scans, then for their creation and creating a data set. The colleagues and I couldn't, make a difference between the scan and a real password. So perhaps next year, one of the subjects should be to give students an assignment to identify fake documents. The next work is from Kirill Romakhov, who developed a remote identification system through face recognition in the core banking system. So this work is clearly valuable in practice. We're talking about 2-factor authentication using a password, which is traditional, and using biometrics. In this case, the human face was used. So basically everything runs on this artificial intelligence, and when validating the user, not a single picture, it's not just a single picture that's being used, but several of them. So based on this sophisticated analysis, positive identification of the customer is happening. The accuracy that we achieved was 99.39%, which is actually quite good. And we can even say that we can use this method to support customers' financial activities. The next work, it's work by Sergey Tkachenko and Denis Yakushev, the developer software platform to manage distributed systems. This work's goal was to create a program platform to manage distributed systems that simplifies the task of simplification from the solution based on .NET Core, moving to distributed execution. The guys chose the mechanism of computation distribution based on the virtual actor model. That is a balanced solution between imperative and functional approaches of organizing the code of the platform. This platform allows also execution in a container, so it's possible to apply it together with container orchestration systems. So as a result, you're not going to get simpler deployment, but also to use the system when the organization already has similar systems. So the system will be able to join the ecosystem of this organization quite quickly and safely. The next slide shows the architecture of this system and also the complete schematic to invoke a method that was implemented in this graduation qualification paper. As you can see, ladies and gentlemen, the convergence between the business community and machine learning professionals at this point was actually quite useful. The master's program allows doing absolutely cool things, graduates, professionals that are highly required in the market and that become fully fledged AI masters. And you can do it systematically from year to year, and I'm hoping that the collaboration of SBIR with Kaliningrad University is going to continue, and we'll be happy to showcase our success stories at this great conference. Many thanks to all of you for your attention. I'm prepared to take your questions if you have any. Thank you.